I'm Jun Shimada from ISS Payload Engineering at JAXA.
I'm Jean-Dominique from Airbus, ISS and Innovation Projects Manager for the European module.
Hi, I'm Nora, and I'm faculty at the International Space University.
Hi, my name is Luis Sia. I'm a research associate at Biosource Space Technologies.
My name is Jason Dunn. I'm the co-founder and chief technology officer at a company called Made in Space.
My name is Julia Stalder, and I'm a mechanical engineer on the ISS RapidScat team.
It should be noted that the camera system on orbit is registered to the International Disaster Charter, and its operation is performed on request.
I supervise the development of projects willing to access the space station and allocate the right resources. I enable the integration of experiments with groundbreaking science impacts on topics such as Earth observation and monitoring, skin aging research, and future planetary exploration.
In 2014, I sent Ireland's first secondary school experiment to the International Space Station. This was made possible through partnership with NanoRacks. Hundreds of students from all over Ireland got involved in the project, and for the first time, they had an opportunity to send their research to the ISS.
Hi, my name is Luis Sia. I'm a research associate at Biosource Space Technologies. I investigate bacterial behavior in space. My PhD thesis conducted on board the International Space Station allowed us to investigate how are bacteria capable of surviving in concentrations of drugs that on Earth would kill them, but also how can we translate this new knowledge into solutions to the drug resistance problem here on Earth.
And last year, we made history when we put a 3D printer on the International Space Station. It allows ISS really to be a gateway for humankind's future in space. We can give this technology to anyone to use as a new way to access space.
My primary role on the team was to lead the mechanical assembly and testing of the instrument prior to its launch and operation. RapidScat is a scatterometer, which is a type of radar. RapidScat specifically measures the wind speed and direction at the surface of the ocean. It does this by measuring how much of the radar signal scatters when it impinges on the ocean's surface.
Before the panelists come on stage, we want to encourage you that you will have the opportunity to ask questions. We do have the mic back there on the right, and so if you have questions and want to sneak over there and be ready for the question opportunity, that's where we'll take questions a little bit later.
And now let's welcome our panelists to the stage. Jun Shimada from Japan, Luis Sia from the US and Guatemala, Nora Patton from Ireland, Julia Stalder from the US, JPL NASA, Jean-Dominique Coste from France, Germany, and Jason Dunn from the US.
So let's begin with Jun Shimada. Jun is a systems engineer at JAXA. He's now leading the Earth observation camera project on the Japanese experiment module. Jun, tell us a little bit more about you and your work.
Thank you, Julie. Good morning, ladies and gentlemen. It's my great honor to be here sharing the story with all of you. Thank you for making this happen. I want to start sharing the idea of Earth observation from ISS. We developed a series of camera systems on the GEM Expo facility with the concept of COTS utilization. By that, I mean the system includes several consumer products such as camera, CPU, and network encoder, which you can buy at the appliance store. This sort of application makes it possible to develop a new system more economically and faster because we don't really need to start from scratch. However, as you know, the environment on orbit is severe enough for these COTS components, so the criteria for selection is based on the actual environment on orbit and launching operation. With that sort of brief background, we are now trying to go a step further with the latest camera mission. It's critical in differentiating the new system from the former one is replaceability. The camera system is launched as a pressurized cargo, then flight crew attached it to the experimental platform named ISS, then passed through the GEM airlock and transferred to the designated port by the robotic arm. With that, we have an easy access to the system in order to replace the COTS components, not in just case of malfunction, but it allows us to chase the fast-growing industry on the ground. And regarding the camera system itself, there has been distinct advancement in the functions. Firstly, smoothly track the targets on the ground using its platform. And secondly, shoot the night view using its high-sensitive camera. Let's dive into the video usage. In addition to education and publicity, the images are used for disaster monitoring. The thing is, the camera system on orbit is registered to the International Disaster Charter, and operation is performed on request. Regarding the new system, with its high sensitivity and tracking ability, the new system has the potential to respond to the wider range of requests than its predecessor. Well, in this talk, I've got a chance to talk about Earth observation with the COTS applied system, and it quite strikingly showed that ISS, we can get great benefits from ISS, and the other side of the coin is that ISS could be used as a test bed for the technology demonstrations in a relatively easier way than uncrewed systems in space.
Thank you, Jim.
And just one more thing. And on top of that, I strongly believe that the video images can make you realize again we share this planet. And my hope is our mission would raise such awareness and ultimately about the importance of nature conservation and peace. Well, those are the major descriptions of what drives me to move forward.
Thank you very much, Jim. And how does a country that, or an organization that's not involved in the ISS request data that you've obtained on board?
Well, basically, anybody can make a request. Once you got registered to the International Disaster Charter, you are good to go. And the request is also made by a group called Sentinel Asia, which is a disaster management activity in the Asia-Pacific region. Thanks for the question.
Thank you very much, Jun. And the ISS indeed can bring benefits to people on Earth in an efficient and quite a timely fashion. But the long-term solutions to problems on Earth are also addressed in some of the longer-term research projects that we have on board. So Dr. Luis Zia from Guatemala and the United States works on a great example of such a project. He's investigating bacterial behavior from Bioserve in Boulder, Colorado, and showing the truly international nature of the ISS. He's also conducted part of his research at the DLR, which was right next door to the European Astronaut Center, and we met one day in the canteen because we both heard each other speaking English in a very German environment. So thank you, Luis.
That is true. Thank you, Angie. Oh, I look so happy in that picture. And indeed, I'm happy to be here and honored, so thank you for having me here. And that's a question that I usually get when I tell my family and friends that I investigate bacterial behavior in space. It's why? Why do you do that? And there's several reasons. I'm just going to touch base on one, and those two pictures are going to help me do that. So if you see the first image, it's actually a test tube, and it has a liquid medium that looks just like water. It's see-through. But in that case, and this is what that test tube looks like, just a tiny test tube, and you see it's not clear, and that's because there's millions and millions of E. coli cells homogeneously distributed throughout the whole volume. And that's why it looks cloudy. And that's a picture of a sample that we culture here on Earth. And the picture below is another similar test tube, But that's a picture I took of a sample as soon as it came back from space. And in space, they seem to aggregate, behaving more like a single entity more than the millions and millions of cells that it was actually composed of. Other investigations have also observed that you need higher concentrations of antibiotics to kill bacteria in space, so to speak. And it's not really well understood why. And the importance of this problem is, or really what I was wondering is why is that so? Why are bacteria capable of resisting concentrations of drugs in space that on Earth would kill them? And can we identify genes, specific, what makes this possible? And the reason for which I'm interested in this is because of the drug resistance problem here on Earth. It's something that's killing over 100,000 people every year of bacterial infections that we can no longer cure with our existing antibiotics. And every year this problem is getting worse. So we can find a gene that currently drugs are not targeting to kill bacteria that we can no longer kill. It could bring benefit to people here on Earth. So the way this was done was, this was part of my PhD thesis and an experiment conducted on board the International Space Station called AES-1, which stands for Antibiotic Effectiveness in Space. And that one launched in Orbital 1, so that's the first flight of Orbital ATK. And we did that by using these test tubes, loading them with E. coli and different classes of antibiotics. And then there were two NASA astronauts that helped us operate this in space, Mike Hopkins and Rick Mastracchio. I heard words around that Rick Mastracchio is in the conference. I'm not sure if you're here, Rick. He's not here. Just wanted to say public thanks. But anyway, thank you to both the astronauts and everybody on the space program who made this possible. And what they did is they attached that crank that you can see in the image to that gap. So this is called a fluid processing apparatus, or FPA, and we would put 8 of these test tubes inside that larger volume that is called a gap. They're both developed by BioServe Space Technologies in Boulder, Colorado. And then the astronauts would crank it, and that would activate the experiment, introduce the antibiotic, and eventually terminate the experiment. One of the things that we found is that cells became significantly smaller, less than half the size of what they were here on Earth. And also, by looking at the gene expression, really the RNA and a lot of other things that we were looking into in this experiment, we are now able to corroborate a theory that's been around for decades that may explain why bacteria behave the way it does in space, but that theory had not been able to be proven either by computational methods or experimental methods, either on space or on Earth. And I think this is just, although AES-1 is a very humble step towards our fight for drug resistance here on Earth, it showed me how the ISS indeed enables and how it is a gateway for humankind's future, not only on space, but also on Earth.
This sounds fascinating. I think this is a great example of the ISS as a gateway to the future, not only in space, but also on Earth. So tell us what's next in your research.
I'm biased towards science. I'm pretty excited about these things. So, but one of probably the most exciting thing that I found with AES-1 is that some bacteria have this mechanism that some people call the suicide genes. Scientifically speaking, really, it's apoptosis. Really, what happens is that the cells burst. And some people think that they do that. They trigger this suicide gene when the culture, the whole colony, so to speak, is under stress, under certain types of stress. And then some of them kill themselves, really, so potentially to provide nutrients to the other ones and then increase the chances of the whole culture to survive, whatever stress they're being exposed to. So one question is, why don't we just turn on that gene on the bacteria that we can no longer kill here on Earth? But the problem is that if you try to turn on that regulator, you're also turning on over 100 other genes that confer resistance to oxidation, to temperature changes, to acidity. So really you're making a normal bug a really bad bug. So you don't want to do that. But something that we saw in AES-1 is that the suicide gene was turned on under specific conditions in space, but the regulator that we know of was not telling it to. So that makes me believe that there might be a new regulator of that suicide gene that we could potentially investigate to see if that could shed light into a new type of a drug, if we could force bacteria to kill itself, so to speak. And by the way, we never saw this on the Earth samples, although we try to replicate that.
Thanks, Louis. That's a great example of the kinds of innovative experiments that can be done on the space station that you can't do here on Earth. Our next panelist is Dr. Nora Patton from Ireland. She is faculty at the International Space University and previously worked as the Communications and Outreach Manager at the Irish Center for Composites Research. Nora, tell us how you got involved in projects on board the International Space Station.
Thank you, Julie. It's a real pleasure to be here today. I'm really delighted to have this opportunity to share this story, so thanks sincerely to everyone who made that happen. So I grew up in the west of Ireland, as you might gather from my accent, and after a family trip to NASA when I was just 11 years of age, I was completely obsessed with space. I just absolutely loved it. And I spent many years focused on my studies, obtaining my PhD, and developing my own space career. And after that, I wanted to bring something back to the younger generation at home. So when I began working as the Communications and Outreach Manager at the Irish Centre for Composites Research in 2013, I decided to do something a little different. I created the Only Way Is Up project. And for the first time in Ireland, second-level students had an opportunity to send their research to the International Space Station. I raised funding through a number of different sources, including writing a successful grant application to the Irish government, and there was huge excitement when this was announced. We signed an agreement with NanoRacks, which would allow one experiment go to the ISS, and throughout the project, we spoke with hundreds of students from around the country about space and exploration and research and why the microgravity environment is important to do research in. The students had obviously loads of different questions about space and why it is important to use the ISS for this type of research. And they began asking their teachers loads of questions. They began watching video clips of Chris Hadfield on YouTube, living and working on the ISS. And it really was an opportunity for them to think and create and design research experiments of what they would like to send to the space station. So in early 2014, after the students were given an opportunity to really do some research and design these projects, more than 140 students submitted abstracts. And then in February 2014, we announced the winner. And this announcement was featured on the Irish National News. It was featured in local newspapers and national newspapers and radio shows, and there was heaps of excitement because Ireland is a country that doesn't have a space agency. We don't have astronauts. We don't have that same supports that would be in America. So it was a new and really cool, different project that was happening. And the winning project then, as you see these 4 young students from Limerick, they designed an experiment to research and investigate the effects of microgravity on reinforced concrete. The experiment, we spent several weeks preparing it to be flight ready. We used all Irish components, which was really cool. And then it launched on board the Orb-2 mission in July 2014. And when it got to the ISS, it was activated by ESA astronaut Alexander Gersk. So he took out the experiment and mixed all the components. And then it spent almost 10 weeks orbiting Earth before coming back on SpaceX. So that really is a testament of commercial space. You know, this little Irish experiment launches on board the Orb-2 and comes back nearly 10 weeks later on board the SpaceX. So I'd really like to leave everyone today just with a couple of thoughts. Instead of asking why, I would encourage all of us to ask why not? Because in a country that has no space agency and no astronauts, I was able to reach hundreds of students from around the country and speak to them about the importance of space. So I'd encourage everyone here today to think about your own country and your own community and ask yourselves how we can use this amazing infrastructure that is the ISS to really impact the future generations and further the knowledge of space. Thank you.
Thanks, Nora. And yeah, Nora, I do remember ESA astronaut working on that. I worked on that with Alex. It was an excellent payload. And do you have any further plans to do more projects like this in Ireland?
Yes, so I've maintained a very good working relationship with NanoRacks since I started this project, and now I have my own startup company in Ireland where I'm specifically using space as a means of engaging and inspiring the next generation. So absolutely, yeah, I do plan to take do similar projects like this in Ireland to bring more space research to the younger generation. And I'm also fully a believer in collaborations. So if there's anyone here today who'd like to talk to me afterwards, I'm absolutely open for collaborations with international partners, and I'm really excited about what the future holds. Thank you.
Thank you very much, Nora. So yeah, for sure, if nothing exists in your country, then the way to change it is definitely by starting something yourself, and we very much look forward to seeing more developments from Ireland in the future. So our next panelist comes from the United States and is a mechanical engineer. Julia Stalder was involved in a project that utilizes the ISS for Earth observation, and as a flight controller, I can tell you it's one of our favorites to watch in the control room on the six-pack. So please tell us, Julia, what was your project all about?
Thanks, Angie. So thank you, everyone. I'm really excited to be here to talk about my involvement on the ISS RapidScat mission as a mechanical engineer on that team. So first of all, I'll tell you a little bit about what RapidScat is and how we got on board the station where we're collecting data even as we speak. RapidScat is a scatterometer, which is a type of radar. RapidScat specifically measures the wind speed and direction at the surface of the ocean. It does this by measuring how much the radar signal scatters when it impinges on the ocean's surface. So if the wind speeds are low, the surface of the sea tends to be smooth, and the emitted microwave signal from the instrument will just bounce off the surface away from the radar, and the returned signal to the instrument will be low. On the other hand, as the wind speed increases, the choppiness and roughness of the surface of the ocean increases, and it causes the signal to scatter in all directions. And so the instrument picks up a stronger returned signal to the radar. So that's the general premise of how RapidScat works. And with this, we can produce these beautiful plots of nearly global ocean wind vector data that you're seeing on the left. I like to point out the plot on the right. It's of Tropical Storm Simon that formed off the west coast of Mexico. And I highlight this one just because this data was taken just 2 days after we were installed onto the ISS. And I think that just goes to show that by us tapping into the infrastructure that the ISS provided, we were able to get this data back so quickly and inform government and aid organizations on the ground. And this, frankly, is just the one of many plots that we've collected. We saw Typhoon Hagaput as it was approaching the Philippines last year. We saw Hurricane Patricia as it was developing and approaching land. And if you remember that unique event last hurricane season where 3 hurricanes were sequentially developing in the North Pacific and approaching the Hawaiian Islands, RapidScat was providing data to scientists so they could study those developments. So my specific role on the team was to lead the mechanical assembly and testing of the instrument prior to its launch and operation. I got to deliver some of my own hardware and then take all the pieces from the larger team and put it together and lead the team that built the 2 payloads. And like with any spacecraft or instrument being launched into space, we put it through extensive environmental tests, including vibration tests and thermal vacuum testing to ensure its successful operation once it was on station. So then following that phase, RapidScat was launched to the ISS, of course, in September of 2014. It was launched in the unpressurized cargo trunk of the SpaceX Dragon vehicle on its 4th crew resupply servicing mission, or CRS mission. After orbiting Earth for a few days, the Dragon docked to the ISS, and the robotic arm, controlled by ground operators in the US, Canada, and Europe, extracted the payload and installed us onto the SDX site of the European Columbus module. And it was really a pleasure to find out that one of my fellow panelists, Jean-Dominique, who will speak in a moment, was going to be here with me today, as he himself played an integral role in ensuring our smooth installation onto Columbus. So overall, RapidScat was a really exciting project to get to be a part of, and I feel really fortunate that I got to be on this small team at JPL. It's of course just a thrill for us to get to turn on the live ISS streams and see RapidScat up there spinning away collecting this data. It paved the way, I think, for other JPL payloads to use the ISS. It's not something that we typically do. It's a little outside of the box for JPL. And I think just fundamentally, it's really a point of pride to know that this instrument is providing data on a daily basis, not just to the science communities that are studying how the atmosphere and oceans interact, but it's also being used by government and aid organizations to inform communities on the ground that would be affected by these storms. Thank you.
So tell us specifically how the ISS enabled this instrument.
Right, so yeah, the ISS was really fundamental to RapidScat becoming a tangible instrument up there. You know, this type of radar, this scatterometer, can only make these measurements from space. And so the ISS provided the platform from which we operate. It's essentially our spacecraft bus. So we get our power and we use, like I mentioned, the telemetry links already built into the ISS to get this data back so quickly. And of course then we get the GNC and the orbit attitude determination, all that data from the ISS that we use to process our data. And then from the science perspective, the unique non-sun synchronous orbit of the ISS lets the scientists study how the winds change between day and night, which is called the diurnal cycles. So that's something that I think RapidScat's one of the first scatterometers that's actually getting to observe this phenomenon as well.
Thank you very much, Julia. Many projects benefit from the unique platform that the ISS provides, and with so many experiments running in parallel, integration of these systems becomes a real challenge in and of itself. Our next panelist is Jean-Dominique Coste. As systems engineer, he's involved in facilitating setting up new projects on board the ISS. Considering the high requirements that cutting-edge science projects often placed in their laboratory environment and the people conducting the experiments, I'm excited to hear what he has to say.
So good morning. I am an ISS and Innovation Project Manager at Airbus Defence and Space in Germany. I actually represent the station when new people want to fly, well, new projects, let's say, want to fly up there. I make sure that they'll be technically feasible in the station and that they're ready to deliver outstanding science. So I supervised 35 projects in total to go to the station, and one of them is the fantastic RapidScat, as just presented by Julia. And talking about that, do we have any sailors in the room? People sailing or surfing? Not any? Okay. Yeah, there's one. Yeah. Great. Well, if you have a plan to go tackle the waves on the San Diego coast tonight, you will probably look at weather data that comes from RapidScat. And let me tell you, it was not easy to get there, but it was very fun. So as facility managers of the station, we look at the project and try to understand how to make them fit into the overall system. So when we saw RapidScat coming, we saw it has a really big antenna that radiates a strong beam with an electromagnetic radiation so strong that anything coming close to it, like an astronaut or a spacecraft, would just get instantly deep fried. So we had to come up with smart control systems to make sure that we would not run into such a situation. And an example is this tiny little jumper that we designed and configured and routed so that it's actually an independent power switch that's manually operated by an astronaut, and it's connected to a connection that's initially for laptops, but we route it so that it actually comes to the power interface of RapidScat. So if we come to an unsafe situation, the astronaut can always unplug. And another interesting example is, well, RapidScat was basically a big, bulky piece of metal. Sorry for that, Julia, but and we attached it at one end of the station. And it actually was so heavy that it changed the center of gravity of the whole ISS. Can you imagine that? So what does that matter? If you have a Soyuz that docks on the other end of the station, and then the Soyuz is designed to another center of gravity, then you trigger a cascading vibration that can end up in a disconnect of one module at the end. So we ran a lot of analysis, to try to avoid a situation like the movie Gravity. So a lot of, mechanical or whatever acoustics analysis. And we derived operational constraints to make sure that in no way we would have gravity for real. But I can say that thanks to our facility managers' work on the station, the ISS is actually much safer than Hollywood wants you to know. Another project that I really like was Skin Bee. But first, let me ask my favorite question. Does anybody in the room want to become an astronaut? Come on. Okay. That's kind of popular, much more than my job. Well, I have bad news for you, because you will actually look older if you become an astronaut. Your skin and your tissues will age faster, but we like that. Sorry, again, because, you know, if you want to study the aging of the skin on Earth, you have to wait for somebody to get old, which takes like a while. And research grants do not last that much of a while. But in space, it's all faster. So you can actually make the first mathematical model of tissue aging. And when you get that model, you can derive, you can tweak it, and then derive treatments to stop it or slow it down. And so in the end, it's not only the astronaut that will benefit from it, but it's you, it's maybe your friends or your relatives. And it's really important that, you know, everything I've talked about so far is just like boring tools and platforms that we work hard to maintain as ISS caretakers, so that in the end, it comes back to you as citizens. And in that direction of democratization, at Airbus Defence and Space in Germany, we actually designed the multi-purpose computer communication system, which is a system that enables anyone on Earth to drive a project on the station from anywhere. So you could be sitting at Starbucks with your caramel macchiato, because everyone loves caramel macchiato, right? And from your laptop, drive a little robotic arm on the station, because we think it's a platform that has to be designed to fit your needs.
And we fully concur. And in fact, ESA will soon have a commercial platform on the ISS using this MPCC, so that you can directly control your payload over IP from wherever you are, even from your mobile phone, as Jean-Dominique described. So as we can tell by your experience, a major barrier for people to access space can be the complexity and the bureaucracy. So is this just the nature of the space industry, or is there something that you can do about it as an integrator?
Yeah, that's a good question. So initially, we worked with a really complex set of processes and requirements to try to cover up any kind of impossible failures. I don't know if there's any Houston people in the room, but you know, failure is not an option, right? Like, you know, in this room, it's easy to use the smartphone, but in space, in this ISS, it emits some electromagnetic radiation that can then interfere with other equipment and lead to failures. But after years of operating the station, we found out that the low Earth orbit environment is actually very friendly, like much more friendly than we thought. You could almost walk off this room, go there, and be okay. So we came back to the drawing board, and we are designing a new set of processes to make it as lean as possible for you to access the station, just like pushing a gate. So what we aim for is that you basically have an idea to use the value proposition of the ISS. You like the radiation, you like the weightlessness, you like the view to Earth, to space, you like the astronauts, and you think you can get great data out of that. And so you think, for your project, maybe you want to use that nice hardware from Amazon because you know how it works, or that from that, you know, that provider that you know, and you come to us, and then you enter a completely automated system that's based on a cloud-based database server, where we take your request and we automate everything to make it a payload on a station. So we look into a database of reflight hardware, of commercial hardware that's qualified. We apply only the requirements that make sense, the one that are only critical to infrastructure safety. And then you run like a little test campaign, we help you, and then within less than a year, you're up there and you operate from your own place. That's really important, because I think a lot of people in this room own a piece of the station from their taxes, and it should be given back to you. I think the ISS is not anymore this piece of elitist governmental pride, right? But for us as facility managers and exploitation managers, it's a platform that we work hard to maintain so that you can benefit from. And when I say you, I'm not talking to the scientists or the engineers, I'm talking to the citizens. Thank you very much.
Thank you very much, Jean-Dominique. And our next panelist represents the entrepreneurial spirit of the next generation. Jason Dunn is the co-founder and chief technology officer of Made in Space, and we're looking forward to what the cooperation between NASA and a startup has brought to the ISS and to space exploration.
Thanks, Angie. It's a real pleasure to be a part of this panel and with such an amazing group of leaders. So my story is one that highlights the success of public-private partnerships between NASA and commercial sector, and really gives a glimpse at where we're headed with our low Earth orbiting assets. So my co-founders and I created Made in Space with this vision of transforming the way we get goods into space by building them there. Just as there is a business in launching things on rockets, we imagined a future business in digital launch. That is, taking a digital blueprint of a thing and sending it to a robotic manufacturing facility in space, and then having that facility take the blueprint and turn it into the actual item. So we imagine that one day everything from a tool for an astronaut to an entire satellite could be made in space. We started by addressing a real need. The astronauts living and working on the space station are often in need of specialty items, things that aren't available on board, things that weren't planned for. And then, of course, with the blossoming commercial industry on space station, you have new entrants who want to put new hardware on station as quickly as possible. So through a partnership with NASA's Marshall Space Flight Center, we designed the 3D print mission. 3D print mission was a 3D printer, and it flew on SpaceX 4 in the fall of 2014. And when 3D print went into operation, it began building the first parts that were ever manufactured off of planet Earth. The mission was a success across many levels. NASA and Made in Space learned a lot about how a 3D printer might be used for future exploration missions. We also learned a lot about what we needed to advance in terms of 3D printing to make the next versions more capable than the current one. But more than anything, we got to see some real use cases of in-space manufacturing, like the time Butch Wilmore told us that he was missing his ratchet tool. And then we went from design of the tool through NASA safety qualification to printing of the tool, all in a 5-day period. And it only took about 2 hours for the actual tool to be printed. So that's physical hardware that went from design creation in software to this picture in Butch's hand in less than a week. Hardware to space in less than a week. So from these successes, Made in Space went on to build a second 3D printer with all those lessons learned. It's called the Additive Manufacturing Facility, or we call it AMF. AMF is in space right now operating. Actually, both printers are operated this week, which was a new milestone for us. So AMF is a commercially operated facility. What that means is that anybody on Earth can now fly hardware to space in the same way Butch got his ratchet. Since AMF went into operation, we've printed, here's AMF. Since it went into operation, we've printed a tool for Lowe's home improvement. We've printed an item that was designed by a student through the Future Engineers competition. We even printed a part designed by a Navy sailor during the National Week of Making. And up next in our print queue, we have satellite parts. So we're going to look at how to build satellites in space, even with this first printer. We have STEM education prints. We have ISS experiments. And really importantly, we have a lot more test prints with NASA, so we can really understand the properties of 3D printed parts and institutionalize this process. So as we think about a journey to Mars, we know how we can bring this along with us. Thank you.
So Jason, this work that you've talked about really, and the story of the ratchet, really shows how additive manufacturing changes the way that a future mission to the moon or Mars might look compared to missions of the past. What is the next step that you plan for Made in Space?
Yeah, so that's a good question. As soon as we launched the AMF, we also launched a website. And this website is releasing interface standards for in-space manufacturing with the goal that we enable the whole community to start developing new pieces of technology that can leverage all of the work that's gone into space manufacturing so far. And we think that will really foster and grow an ecosystem for in-space manufacturing. We're also looking forward into the future. We just started a contract with NASA through the Tipping Points program. It's called Archinaut, or like Architecture Astronaut. And this is separate from the space station. It's a free flyer that one day will go into space and start to build objects on orbit far bigger than you could ever launch. So imagine the things that we've never been able to put into space because they couldn't survive the launch environment or fit into a rocket. Yeah,
Thank you very much, Jason.
And yeah. So as a reminder to everyone, just like at San Diego Comic-Con, there is a standing microphone on the left of the room. So please feel free to think up questions and come and ask the panelists questions from that microphone. So while people are moving over there for questions, I would like to ask the panelists something. So what, for you guys, was the most important thing that you learnt when you were doing your work on the International Space Station?
Well, what I've learned through camera missions is how influential the space program is. Every single time I'm showing the video images to somebody, their eyes are shining. For me, it's my personal mission is to keep people attracted by space exploration, inspiring the next generation. I thoroughly enjoyed being part of it.
Something I learned is the fact that things that most times we would think are unachievable, maybe. I would never thought I would be working on space projects when I was younger. I was not that great a student when I was in high school. And just working really hard and with the support of my family and friends. And of course, there's also the luck factor of things that put themselves in the right place at the right time. But definitely with a lot of work, these things were possible. So working on ISS showed me that that sky is the limit. Or sky is not the limit, I guess.
Yeah. I think I'd have to say the importance of collaboration. And I think even in all of us coming to these conferences, we can meet people that in future we'll be able to work with on different projects. So it can be quite difficult and daunting, I suppose, when you're starting out on a project not knowing exactly what to look out for. So in talking to people who have done similar projects in the past, you get a better understanding of how the process worked for them. So definitely in collaborating, you can really open up opportunities that before wouldn't have been achievable.
Excuse me. I would definitely second what Nora was saying about what we can do with collaboration across many countries and across government agencies as well as commercial partners. But in my experience on RapidScat, it was a really great reminder from me. I mean, I'm in the aerospace community, and it was a good reminder of how adapting and evolving the ISS is. I was asked a question once from someone who doesn't work in aerospace and said, well, isn't that like really outdated and incomplete? And I was shocked, and I was saying, no, not at all. I mean, we have payloads studying Earth, so we can learn more about our planet. We have payloads looking to the center of our own galaxy. There's biology experiments happening, material science going on. There's so much happening, and I know this too because it affects our data and we have to account for it, but the ISS is constantly changing configuration and moving modules around to accept new visiting vehicles and new payloads. So it was a good reminder for myself too about how dynamic and state-of-the-art it actually is.
For me, it's the realizing the importance of the I in ISS, so the international component. So I work with teams coming all the way from the backcountry of Hungary to downtown Los Angeles, and it's so amazing to see that the drive that the people have is exactly the same. They do it for their country, they do it for their inner child, whatever, but they all have the same motivation. And sometimes I have the feeling that the ISS is some sort of upper house for mankind, where like frontiers or barriers are just like some fake stuff put up by politicians, and actually we're all the same in the end. And I'm just talking about the people that had the chance to reach the station. But there's so many other people we haven't reached yet. And we're doing now this outreach effort in my company to go to non-space business and tell them about the station. And the first reaction is like, I can't go there, it's just too complicated, it's too elitist. And no, it's not. And when you try to explain them that it's possible, you see their lights, their eyes shining. And so I think there's a lot of potential to be realized there.
So one of the things that I've learned and come to appreciate early on when we did our first mission was the amount of support that's within NASA to keep the space station going. When we started the first mission, the team at Made in Space was only 9 people. So we built that partnership with Marshall, and the team became much stronger and much bigger, and that's what led to that mission being such a good success, and it ended up flying very quickly, performed very well. The printer's still operating. So that ended up teaching our company a lot about how to build flight hardware for a station. And when we went off and built the second printer, it was with all the lessons learned that really NASA helped teach and ingrain within Made in Space.
Thanks. I'm going to stand so I can take questions from the audience now. Just be sure to say who you are and what you're representing. Go ahead, Frank.
Yeah, Frank Slaves with Aerospace Industries Association. Occurs to me, a lot of people my generation kind of grew up during the Apollo program, and that became kind of the touchstone that really inspired us to go into this field. For your generation, ISS may have taken that role, and I guess that's part of my question. If some of you have any stories you might tell, was ISS an inspiration for you going through your academic years, through your early professional career? How did it impact where you are today, besides the obvious work you're doing right now?
Does anyone in particular want to take it?
I remember watching the news in Guatemala about the ISS being built one day, and then when one module went up, first through a Russian rocket and then eventually through the shuttle as well. And I was just following that, and I was imagining how cool is that going to be. And for sure it had an impact on me. And I didn't get to live on Apollo era, but the shuttle as well was very inspiring.
Yeah, maybe to add to that, for me it was a lot about the shuttle. I had my physics teacher in high school was one of the final candidates that would have flown on Challenger, and so there's some inspiration there. I went to school in Central Florida so I could be near the Cape, so I could work on shuttle. And at that time, I had no idea that shuttle was even slated for being retired. And I had the privilege of getting to work on shuttle as an intern and be inside of Discovery for one summer. And then I also watched the program get retired while I was in school, and I kind of saw this like dream slip away. But I've met people since that were in the Apollo era, and some of them call themselves the orphans of Apollo. They grew up watching Apollo, and they thought, well, surely we'll be living on Alpha Centauri when I'm older, and then they feel like that didn't happen, and then they became inspired to build everything that we have today. For me and for my colleagues when we were in college, we looked at the shuttle being retired, and we felt a little bit of the same way. We called ourselves the orphans of Atlantis, because that was the last shuttle flight. But it was really important for me because it allowed me to see where the space industry was headed and the transition to a lot of commercial, and really how if I went off and did these things entrepreneurially, I could actually help NASA achieve their mission in a different way than what was possible in the past.
I will add one quick thing to that as well. So from an international perspective, shuttle was a little less significant for us, but so in Australia in particular where I grew up, we watched the international, in primary school, we watched the International Space Station being built, and I was already a bit of a Trekkie by then as well, and I watched the chief engineer Torres on Star Trek Voyager making everything electrical and mechanical work in space, and I was like, I'm going to do that, and then the space station was being built, I'm like, yes, that's what I'm going to work on, and that led to me being a flight controller and mission control. So directly the ISS for me.
Let's go ahead with the next question.
Thank you for your time. My name is Kimi. I'm a biomedical engineer. I work in the aerospace industry. And my question is that as a young entrepreneur, I know that the ISS section, American section of it, has been released as a national laboratory. There's a lot of commercial sector going on. I know ESA has recently started doing that. And I was wondering what percentage of ISS today is possible to be used for a young generation like us as a commercial use, especially for as far as the European station goes and the other Russian station and the rest of them goes. Thank you for your time.
Thank you for your question. I can just speak for the European part, as you mentioned in your question. So as of today, the access was primarily for science-based institutes. It's opening up to entrepreneurship with the new platform called Bartolomeo that will be installed outside of the station. So that's only for external external payloads of any sort, of any commercial applications. So that's certainly open for all entrepreneurs. And there are going to be other initiatives also to open the inside of the Columbus module to entrepreneurs. So the one is the ice cubes from space applications. And in Airbus, we also work on similar concepts. So I'm pretty sure that in the coming couple of years, the Columbus module will be open to entrepreneurs, definitely.
Next question.
Oh, hello. I'm Bess Dawson-Hughes, one of the directors of the Center for Advancement of Science and Space. And I would like to get thoughts of our young entrepreneurs here on some of the barriers that you faced in conducting your research and how you overcame them.
JC.
Put me on the spot. That's a good question. So we took an interesting approach. I could say I think this goes for anybody in the entrepreneurial world, is funding. And we took an interesting approach. We actually were based in Silicon Valley and we never took investment, which usually surprises a lot of people. The idea behind that was that if a 3D printer was really useful on the space station, then we should be able to go work with the partners on the space station to fly it. And so for us, the barrier to entry was we went down the process of going into NASA and writing proposals, and that brought us into the SBIR, the Small Business Grant world, and we developed the technology through SBIR technology. So I would say that, there's the timelines associated with flying, building hardware through, like from SBIR phase 1 and up. Whereas if, maybe if we flew a printer not on station and as a free flyer to begin with, and we funded it with venture-backed money, maybe we would have flown much sooner. But that wouldn't have really satisfied the objective for us, which was to prove that 3D printing was useful by putting it in the place where people currently live.
Yeah, I was also going to say funding. Like even to run that one nanoracks experiment in Ireland, I got multiple funding off different organisations. So the government, the university, the company, the centre I was working in. So that is obviously, I think for a lot of people who are wanting to do it, there's supports and infrastructures there to send research to the ISS, but if you can't fund it commercially, it's not going to go anywhere. So I don't really know how to, how do you combat that? I mean, it's perseverance. It's probably for the likes of educational experiments. It's getting industries and organisations in your country to back projects like this. So it is really, I think, having done one, you can always learn from that and build on it. But funding is obviously going to be a huge barrier if you can't afford to put it up there in the first place.
Next question.
Hi there, I'm Brian Barnett. I'm founder and CEO of Solstar. And so we're a startup that is developing technologies to provide commercial internet services in suborbit and orbital space. And shout out to the other International Space University alumni. We started our company we're all alumni, Michael Potter and Mark Matosian, who some of you guys probably know. Anyway, just way to go. That's basically what I wanted to say.
Thank you.
And we see you all as our customer base as well.
Excellent. Thank you. Yes.
I'm Keith Henson, probably best known for founding the L5 Society some 40 years ago. Recently, the CO2 issue has become a big problem, and it looks like the solution to it may be in space. So when you're thinking about space manufacturing stuff, think about it in terms of millions of tons per year building power satellites. If you want to follow the current thinking on this, there's a group called Power Satellite Economics that you can sign on to. And I'm just curious as to what you all would think of on an order like 4 or 5 orders of magnitude increase in the size of space activity.
Yeah, well, just speaking personally, when I was in college, I was handed The High Frontier, Gerard O'Neill's book, and that book is one of the things that started me on my path of thinking about manufacturing in space and thinking about how we could do space differently. So right there with you with L5 Society and thinking about building things like solar power satellites in space. But for us, we've started with those things are the vision, those things are one day can happen. What is the business that can exist today? As as a bunch of young guys starting a company, it was where do we build a business that if we can keep it growing, one day it helps enable those things to happen. So yeah, we definitely think a lot about that.
If you want to ask me for a card, and it points you to a site where there's pointers to a couple of videos, one of which was shown in April on power satellites as a solution to CO2 at the White House.
Okay.
So things are moving.
Okay, great. Thank you.
I'd like to expand that question and close our plenary with one last question for all of our panelists. So you've heard they've had this great experience on the International Space Station. Some of them have concrete plans for the next thing on ISS, but I'd also like to hear their perspective much more broadly about what they see as the future, both late in the space station's lifetime and then afterward.
Well, what I envision for the future is the age where everybody has an access to space. And with a focus on future space exploration, ISS could be used as a platform for the technology demonstrations, such as eclairs, radiation protection, and the list goes on with no limit. And in terms of my future work, I'm really passionate about fully utilize ISS in order to establish the next stepping stone toward sending humans to deep space destinations. And for my work, I'm really passionate about tech demos on space radiation measurement and protection. That's my future work.
For what happens after the ISS, I think, or I would hope to see more both national and commercial space stations and dedicated for different purposes, for example, commercial projects, but also for educational ventures. So I would love to teach in a university that actually has a campus in orbit, for example. So you go to a lab and don't simulate microgravity. Go up there and actually perform your experiment there. And I think it's not completely impossible to see that in my lifetime. So I think, and I would hope that's what happens after ISS.
I'm going to say the moon. I think when we were at the IAC in October, there was a plenary with the heads of agencies, and the ESA DG got up and he said, you know, a village starts with the first house, and that's exactly it. And I think everything that's happening now at ESA in terms of going to the moon and expanding our research and base there, I'd obviously like to go there myself someday if the opportunity arises. But I think post-ISS, I could see there being more opportunities in that.
Thanks, Matt. Yeah, so I think I would just like to follow up and say too that RapidSCED gave me the perspective that really anything is possible with a lot of cooperation among many small teams. We had help from government agencies, NASA, ESA, and a lot of commercial partners like Airbus and SpaceX to get the instrument installed. It went from idea conception to collecting data in I think under 2.5 years, which is lightning fast for an instrument of this complexity. So I think the possibilities are endless. I agree with Nora that it could be a stepping stone for moon developments, but I would also like to see it as a stepping ground to get to Mars. I know I'm a little biased because I'm at JPL, and so I have a passion about interplanetary missions, but I think it'll be a great proving ground, as we heard from Mark and Scott yesterday, for doing longer duration studies to figure out how to get to the next planet.
Okay, the first thing I see is that now consumer technology, consumer tech is actually outpacing space technology in a lot of areas. So we are really happy in the station to use Google and Apple products. They are very well designed. They are much more efficient than ours. They are user-friendly. And we actually now start to use them not only as a help for astronauts, but also integrate them in products that we're going to sell for scientists or commercial users. So I see first that commercial consumer tech will populate the space infrastructure that we build. And that will only bring people closer to space, because they will realize that, oh, actually, this thing that they do in space is not something so complex. It's something exactly like what I have in my pocket. So it helps to democratize the field. The other thing is automation. So as in every other areas, automation is rapidly growing in space in general and on the ISS. So if any of you will become an astronaut in 10 years, I'm sure you will have a much better time than the astronaut today. You will just enjoy the ride and everything will be done by robots. And the last thing is I feel that we are in a sort of new Renaissance era. It's like if you look at back 500 years ago, it's about the same story. So we are now emerging from about 100 years of conflicts. And we have the luxury to ask ourselves the question, what do we want to do in low Earth orbit? That's like a first world problem, as people say. And just the fact that we have this luxury, I think it's a very positive sign that we are on the kickstart of an orbital economy. So I really encourage you to jump on the train or jump on the Soyuz, should I say, to kickstart this economy and enable commercial sector to thrive in low Earth orbit. And yeah.
I think that space still has so much left to offer us. We're at like just the beginning. We've been going to space for half a century, but we still have so much more to do. We have about 10 years left of ISS, which means for part of what the future looks like, it's how do we utilize that? Bill Gerstenmaier was saying a couple days ago that now's the time to really, really understand how to use ISS and to build new technologies while we have that asset there that allows us to then think about how we send people further and further into space and onto Mars. But then we also, as Jean-Dominique is talking about, we have to think about what happens to low Earth orbit. It looks as if the best thing that happens is that it is commercialized, that the economic sphere moves a little further out. And today we have an economic sphere in space. It's about sending ones and zeros up and down to telecommunication satellites. And now we're starting to get to the point where we think about sending other things like atoms and making things in space. Making things in space that we can bring back to Earth. We often forget that we live on a spaceship. Earth is one giant spaceship, and we're all space explorers, is what I tell people. Only a couple people in this room, I guess, have been off of the spaceship, and hopefully more of us get to leave one day. But there's no reason that we have to do everything we've always done here on this spaceship. We can bring industry into space, and we can make our spaceship a better place. So as we go out and we learn how to live independently from Earth and live on the moon in Nora's moon village, or we go to Mars, we're inventing new technologies to live there. We're basically bottling up a little bit of Earth and bringing it with us, right? Like the space station is a little bottle of Earth, and when we go to Mars or onto the moon, it's the same thing, and we have to invent technologies that allow us to live there. But if we're going to live there for a long time, we have to invent new technologies. We have to invent life support systems that can sustain themselves or bioregenerative in ways. So as we do that, we make this spaceship better. And I think that's what excites me the most, is the idea that Earth becomes a much better place as we move further and further out.
Thank you very much, everyone. This hour has gone by incredibly quickly. It is time now to enjoy lunch. Thank you all for listening to our panel, and join me in giving them a big round of applause.